What happens when an observation is incorrectly worded? A wild goose chase, a pointless or hopeless pursuit. As presented in the previous video, the incorrect wording of observations leads to the creation of erroneous theories and beliefs such as phlogiston and gravity, which are proven invalid and false by the scientific method. The impact of inaccurate wording of an observation will be demonstrated once more. This is the compound copper sulfate. Dissolving the copper sulfate in water produces a copper sulfate solution. This is copper sulfate solution. Put some iron nails into the copper sulfate solution and leave for a short time. Observe the nails and solution. Take the nails out of the solution. Here we have 4 nails, 2 on the left, the nails that were not in the solution, and the 2 on the right, the nails that were in the solution. How the observation is worded at this point is critically important. Incorrect wording could lead to the wrong theory being formed and propagated for decades, even centuries. The observation could be stated in the following 2 ways. Statement 1. A new chemical can be observed that was not previously present. Statement 2. The iron metal has changed to copper metal. Statement 1. A new chemical can be observed that was not previously present. This is an accurate statement. It only includes exactly what is observed and contains no assumptions. This statement will not lead to the creation of erroneous theories and beliefs. Statement 2. The iron metal has changed to copper metal. This is an incorrect statement. It includes assumptions. This statement can lead to the creation of erroneous theories and beliefs. Statement 2. The iron metal has changed to copper metal. This incorrect statement can lead to the erroneous belief that one metal can be changed into a different metal, which could lead to the creation of the wrong theory or belief that base metals can potentially be turned into gold, alchemy. Assumption, a thing that is accepted as true or as certain to happen without proof. Supposition, a belief held without proof or certain knowledge. A very incomplete brief history of alchemy. The introduction of alchemy to the West came in the 8th century when the Arabs brought it to Spain. From here, it quickly spread to the rest of Europe. The Arabian belief was that metals are made up of mercury and sulfur in varying proportions. Gold was seen as a perfect metal and all others were less perfect, an idea popular among Western alchemists. It was a very popular idea indeed that these lower metals could be transmuted into gold by means of a substance known as the Philosopher's Stone. The stone is also believed to be able to confer immortality. The Chinese name it for being the pill of immortality. In Europe, alchemy led to the discovery of manufacture of amalgams and advances in many other chemical processes and the apparatus required for them. Eventually, by the 16th century, the alchemists in Europe had separated into 2 groups. The first group focused on the discovery of new compounds and their reactions, leading to what is now the science of chemistry. The second continued to look at the more spiritual, metaphysical side of alchemy, continuing the search for immortality and the transmutation of base metals into gold. This led to the modern-day idea of alchemy. In March 2016, the Chemical Heritage Foundation bought a 17th century alchemy manuscript written by Isaac Newton. Buried in a private collection for decades, the manuscript detailed how to make philosophic mercury, thought to be a step toward making the Philosopher's Stone, a magical substance thought to have the ability to turn any metal into gold and give eternal life. From the historical sources, it would appear that the idea of changing base metals into gold by chemical and mystical or spiritual techniques existed for quite some time, hundreds of years. Where and how did this belief, idea, and challenge originate? Did the observation of a piece of metal in a very dilute solution of another metal compound result in an incorrect worded conclusion that led to a wild goose chase? During the Middle Ages, Around AD 400 to 1400, another displacement reaction completely misled alchemists into foolishly pursuing a philosopher's stone that was believed to have the power to turn base metals such as iron and lead into more precious metals such as silver and gold. The alchemists' ignorance of relative activities of metals led them to believe that they had turned iron into a more precious metal when they inserted an iron rod into a blue copper sulfate solution. So what is happening here? According to today's chemical theory, a displacement reaction is occurring. A simplified definition: a metal displacement reaction is a chemical reaction in which a more reactive metal element displaces a less reactive metal element from its compound. Here is a simplified version of the reactivity series. The reactivity series for a small selection of metal elements opposite indicates that iron is more chemically reactive than copper. Iron, more reactive than copper, and copper sulfate, which is less reactive than iron. The iron, a reactant, is placed into the copper sulfate solution, a reactant. When a copper 2 positive ion of the copper sulfate solution comes into contact with an iron atom of the metal bar, a transfer of 2 electric negative charges, electrons, from the more reactive iron atom to the less reactive copper ion takes place. Before and after. When the 2 negative charges, electrons, transfer from the iron atom to the copper 2 positive ion. 1. The positive and negative electric charges of the copper becomes balanced. The copper atom now contains the same number of positively charged protons and negatively charged electrons. Now the copper atom has 0 overall electric charge and is not soluble in the solution. 2. The iron atom becomes a 2 positive ion because it now has 2 positively charged protons in the nucleus that are no longer being balanced by the 2 negatively charged electrons that were transferred. The 2 positive iron ion is now soluble in the solution. The more reactive iron has displaced the less reactive copper ion from its compound, copper sulfate, and taken its place. The displaced copper forms a solid layer which at a certain concentration or amount becomes visible to the human eye. The less reactive copper is displaced from its solution by the more reactive iron and forms a solid, visible layer. Another displacement reaction. Copper, a solid, plus silver nitrate, a solution, becomes silver, a solid, and a copper sulfate solution. As demonstrated, the incorrect wording of an observation or idea can lead to assumptions that result in nothing but tail chasing. Unvalidated assumptions have led to people chasing the mirages of gravity, phlogiston, and alchemy for decades, even centuries. The first true alchemist in medieval Europe was Roger Bacon. His work did as much for alchemy as Robert Boyle's was to do for chemistry and Galileo's for astronomy and physics. Bacon, 1214 to 1294, was an Oxford Franciscan who explored optics and languages in addition to alchemy. The Franciscan ideals of taking on the world rather than rejecting the world led to his conviction that experimentation was more important than reasoning. Of the 3 ways in which men think that they acquire knowledge of things, authority, reasoning, and experience, only the last is effective and able to bring peace to the intellect. Experimental science controls the conclusions of all other sciences. It reveals truths which reasoning from general principles would never have discovered. It is only the application of the scientific method, the arbiter of cause and effect, that prevents us from chasing ghosts by invalidating any erroneous thought, word, idea, or claim. The application of the scientific method prevents a wild goose chase and stops erroneous theories, beliefs, and assumptions from leading people down the garden path. My sincere thanks to Karen B. for her technical support in the production, and dedicated to Beyond the Imaginary Curve, please check out the YouTube channel.